Kirkle Math. All right, here we are, another lesson. We're finally moving away from 3.1 and on to 3.2, absolute value and opposites of rational numbers. So our objectives are in this lesson is that you can find the absolute value and the opposite of a rational number on a number line. We already know what an absolute value is and what opposites are, but we did those with whole numbers and their opposites, integers. So we're going to do this now with some rational numbers, with fractions and decimals, as well as just review absolute value and opposites in general. So open up those notes. Okay. We are reviewing right now just what an absolute value is in general. So an absolute value is a number's distance from 0 on a number line. Write these down. We're using these absolute value symbols right here. They look like two parallel lines to show absolute value. And absolute value will never be negative. Absolute value will always be positive. All right. The absolute value of -3 is +3 because it is 3 units away from 0. And we model this on a number line by showing, so you can see here they have a number line. They have a dot on the number that we're trying to find the absolute value of. So we have a dot on -3. And then they use this kind of bracket, or you could use hops, like that, to show that that's 3 units away from 0. I don't need to go past 0 because 0 is what I'm basing my absolute value on. I want to know how far away is this number from 0. So I'm just going to hop to 0, count that out, and that's my answer. So on the number line above, we counted 3 units from -3 to 0. So it is 3 units. That means that the absolute value of -3 would be +3. The absolute value of +3 would also be +3, and that's because they are opposites. So we will say something like 3 and -3 are opposites. Therefore, they have the same absolute value, or are the same distance from 0. All right, pause this and make sure you have that nice long sentence down. All right. So now we're going to do some examples. So this first one is super simple. We have the absolute value of -2. So not only are we going to write the absolute value of -2 as +2, but we have to prove our answers on this number line. So we're going to do like they did. We're going to draw that dot on -2, and we're going to show the distance to 0, or the hops, which is 2. So therefore, I proved that the absolute value of -2 is +2 because it is 2 hops away from 0. For B, we have the absolute value of +5, which is +5. And again, to prove it, we're going to draw our dot and then show the distance. 1, 2, 3, 4, 5. The absolute value of 1/2, now we're getting a little tricky, is 1/2 because it is half of a hop away from 0. So I need to draw a dot where 1/2 would be, +1/2. And then I can show my hop of 1/2 on the number line. And then the last one is D. And that is -3 4/10. And the absolute value of -3 4/10 is 3 4/10, because if I draw -3, and then remember, half is 5/10, so 4/10 is going to be a little less. negative 3 4/10 is 4/10, 1 4/10, 2 4/10, 3 4/10. It is 3 4/10 away. All right. So I want to go ahead and move this down a little bit because I want to show you this sentence down here. So I just demonstrated all of this and proved my answers on a number line by drawing different models. But another way you can prove your answer is by writing a statement, and that statement is right here. The absolute value of blank is blank because it is blank units away from 0. So if I was doing this for D, I would say the absolute value of negative 3.4, because that's the number inside my absolute value sign, is positive 3.4 because it is 3.4 units away from 0. All right, pause it and write it down. All right, so now we're going to practice. So we are going to find the absolute value of each number, which is the easy part, but then you're going to prove your answers in one of two ways. You can either draw a number line model or write a written statement like that sentence we just did on the previous slide. Okay, so go ahead and do all 4 of these, either writing a sentence or drawing a number line as proof. If all you do is write the answers, that's not worth anything. I need proof. You need to prove it so that you can get in the habit of saying that phrase or writing a number line. All right, so you could have drawn 4 individual number lines. I kind of tried to sketch out just one, but my proof that 87, the absolute value of 87 is 87, is because it is 87 hops away from 0 on a number line. It is 1/4 away from 0 on a number line. And if I was writing this out, I would say the absolute value of negative 2.3 is positive 2.3 because it is 2.3 units away from 0 on a number line. All right, more models. So now that you've written this out or you've drawn your models, we're going to do some more, but we're going to do them with number lines that are kind of made for us. So the number lines that are whole numbers are drawn for you, but the number lines that are rational numbers, you need to fill in. And there are 2 ways you can fill in your models, your number lines here for rational numbers. So you can do the traditional 0, 1, 2, -1, -2. And then you would have negative 1.5, negative 1.25, negative 1.75. You'd have your dot here, and then your model would look like this, because our answer is going to be positive 1.25. Or you can have your number line be like this, with 0 here, negative 1.25 here, negative 1.5 here, negative 1.75, and negative 2. Notice that I still get to negative 2 in the same way. I just moved my 0 over. And if I do it this way, then my dot would go here, and I would be moving it here to 0. Both of these, the blue top one or the purple bottom one, those are both accurate and correct. You have to decide how you want to set up your number line. Do you want to divide it into chunks based on the rational number? Or do you want to divide it into whole numbers and then estimate where your rational number goes? So go ahead and finish these, -5, 7, 3/4, and -5/10, and then come back and see if you got it right. Phew, that was a lot of work, but good job. So hopefully you got your -5 and your 7 correct, and they both go to 0. We're not going to go past that. We're not making our count into our opposites. We're just doing the one side to find absolute value. And then if you did whole numbers for 3/4, this is what your number line would look like. And if you did halves for the last one, then this is what your number line would look like. All right, one more piece. So on these word problems, they have tricky sentences we have to say true or false to. The distance from -4 to 0 on a number line is the same as the distance from 4 to 0 on a number line. True or false? True. The distance between -20 and 0 on a number line is the absolute value of -20 units. True. The absolute value is the distance between that number and 0, so those are the same thing. On a number line, the absolute value of -3 and -3 are the same point. False. The absolute value of -3 is +3, so therefore it is not the same thing as -3. All right, here we've got sea level and we've got some turtles, and we want to know what's true. Turtle A is deeper than turtle C because the absolute value of -3,545 and 1/10 is greater than the absolute value of 4,356. I think there's an extra number in here. It's 0.7. Yeah. We're not supposed to have this extra 7. Doop. And the answer is false, because 3,000 is not greater than 4,000. So when you do the absolute value, it doesn't matter that this one's not negative, which it should be. When you do that extra, or do the absolute value, this arrow, this integer, can't think of it. Inequality sign is not correct. Turtle A is deeper than turtle B because the absolute value of -3,545 and 1/10 is less than the absolute value of -3,476.6. This one's tricky. It says A is deeper than B, which is true. However, this is not true. The statement is true, but its proof is false. Therefore, it's false. Phew. All right. It's a lot of interesting work for absolute value and opposites with fractions and decimals and rational numbers. Go make sure you have your notes filled in all the way with all of your work shown. And if you have any questions, come see me. Until the next one. Bye.